Hi everyone, welcome to my channel. I'm your instructor today. And we will discuss the physical and chemical properties of fuels and lubricants. So this is the continuation, which is contaminants. So our STCW function 1, marine engineering at the operational level. Competence, plan, and schedule operations. KOP, which is knowledge, understanding, and proficiency. Physical and chemical properties of lubricants. So our learning outcome. At the end of this lesson, the students should be able to outline procedures for dealing with contamination of oils by water, fuel and lubricating oil, solid debris, or other contaminants, including recognition of unacceptable levels and possible consequences. Examine the causes, symptoms, effects, and methods of treatment of oils that have been infected with microbiological organisms. So let us proceed. Introduction. Microorganisms, bacteria, can exist in lubricating oils and fuels under suitable conditions. They can grow and multiply at phenomenal rates. Their presence leads to the formation of acids and sludge, metal staining, deposits, and serious corrosion. The presence of smell indicates contaminated system. So we have here the effect of water contamination in oil. In a lubricating system, the two most harmful pieces are free and emulsified water. In journal bearings, the incompressibility of water relative to an oil can result in a loss of hydrodynamic oil film that in turn leads to excessive wear. As little as 1% water in oil can reduce the life expectancy of a journal bearing by as much as 90%. So we have here a graphical representation. So percent of water in oil and percent bearing life remaining. So appearance cloudy and appearance normal. So it says here even 1% water in oil can reduce the life expectancy of a journal bearing as much as 90%. So 1%. So here is what we call. So if you put this graph continuous there, it will be arrive 1%. So here is 90% the lifespan of your journal bearing. But here you have we have the graph. So if you cross this graph, you see 0.025. So in cloudy appearance. So if you cross this one here, it will reduce the life expectancy of the bearing about 20% here in a cloudy condition. But here 0.2, 0.20, so around 20, 23, 24. So at normal condition, so normal is allowed is 0.1. So 0.1. So 0.1% of water, your percent bearing life remaining is 30%. But here at 0, you have 100%. 100% life bearing, percent life bearing remaining. But if you have already 0.05, so you have 40% bearing life remaining. So if you have here 0.1, then you have 30% life bearing remaining. So water can deteriorate your bearings because of what we call the incompressibility of water relative to oil can result in loss of hydrodynamic oil film. So that in turn leads to excessive wear. So bearing. So let us proceed. So for rolling element bearings, the situation is even worse. Not only water will destroy the oil film strength, but both free and emulsified water under the extreme temperature and pressures generated in the load zone of a rolling element bearing can result in instantaneous flash vaporization causing erosive wear to occur. So there is an erosion of your bearing. So water emulsified, you see? Emulsified meaning water is entering into your lube oil. That is emulsified. Emulsified. So let us proceed now. So the effects of water in lubricants. So not only does water have a direct harmful effect on machine components, but it is also plays a direct role in the aging rate of lubricating oils. The presence of water in a lubricating oil can cause the progress of oxidation to increase tenfold, resulting in premature aging of the oil, particularly in the presence of catalytic metals such as copper, lead, and tin. So meaning, premature aging of the oil, supposedly your oil supposedly will run the machinery up to 1,000 hours. So since of premature aging of oil due to the contamination of water, it may be probably in 100 hours you will change oil. So that is premature aging of the oil. So as you can see here, the effect of water in your bearings. If there is water, the effect here is corrosion. So if there is corrosion, your bearings will be stuck, will be broken, and your machine will be broken. So that is the effect of contamination of water to the lubricants. Next. So we have here the question. We have here the question. So, what is the fuel oil dilution and why is it a problem? So, fuel dilution in oil is a condition caused by excess unburned fuel mixing with engine oil in an engine crankcase, hydrocarbon based fuel, usually with a lower vapor presence than lubricant, has a thinning effect, lowering the oil viscosity. Oil film strength is reduced, increasing the cylinder liner and bearing wear. So as you can see here, we have the EGR. So exhaust gas recirculation. So exhaust gas recirculate here. And we have here the post-injection. So post-injection, we have also the oil layer here, absorption, and we have the blow-by. Now, post-injection, meaning you have here the, what we call the, there's a problem of your injection of fuel. So it might be the unburned fuel will penetrate here through your piston rings when there is blow-by. So it will be going to your crankcase. You have also the AGR, exhaust gas recirculation. since your piston ring is blow by, so it will flow here the exhaust gas, and it will go into the crankcase, and it will create carbon oil layer. So go there. So sources of excess fuel in engine lubricants are EGR, exhaust gas recirculation, post injection, late injection. So late injection. So if there is a late injection, the fuel is not burned properly. So oil layer, absorption, and blow by. So it will be going to the crankcase to contaminate your lube oil. So that is fuel oil dilution. Now let us proceed here. We have also the question here, what is microbial or microbiological growth in fuel storage and tanks? So as you can see here, there is a just like a virus. So fuel tanks and other storage systems are common thriving places for aerobic and anaerobic bacteria given the right set of conditions. So when left untreated, it can lead to the development of dirty slime in the fuel, which can clog the filters and strainers in the tank. It can also cause tank corrosion and fuel spoiling. So microbial growth can cause what we call can damage your lube oil and fuel, and this can clog to filters and strainers, as well as your tank will be have a lot of corrosion. So next, so microbial growth in fuel storage is triggered by fungal and bacterial growth. Fungus and bacteria have fuel as their primary source of food. They also prepare kerosene or diesel fuel over gasoline. The latter is not really a good food source of fungus because its composition contains lead and other elements which can act as a poison to the bacteria. So bacterial growth on the oil tank, fuel oil and lube oil tank is very much not advisable. So the condensation of water vapor within the diesel fuel tanks moreover also creates condition suitable for microbial growth and contamination within the system. Severe contamination is needed by these microbes to grow and propagate. Since oil and water in fuel doesn't mix, these microbes grow in the fuel-water interface, which is usually formed at the bottom of the tank. So since the density of the water is more heavier than the density of oil, so the oil is on top. So the water is at the bottom. So the microbes can grow at the bottom of the tank because the water is there. So next, so as you can see here, this is doing inspection. What are the question? What are the consequences of microbial growth in the fuel tanks and storage systems? Fuel degradation is primarily result of microbial contamination in fuel tanks. One sign of the presence of contamination is the changing of fuel color. This problem can also lead to the problems like reduced combustion efficiency, poor detergency, and elevated cloud and pour point. It can also increase the chances of fuel corrosion and also clog fuel filters. So this is doing inspection. So we have also here the question, how to prevent microbial growth in fuel. The best and most effective way of tackling this problem is prevention. Basically, keeping fuel tanks clean is one of the best methods to avoid contamination. This preventive evaluation of fuel tanks can be broken down into three parts, namely fuel monitoring program for the microbes, fuel system maintenance, and fuel treatment. We have also here fuel monitoring. So fuel monitoring, this part involves periodic testing and sampling of the fuel. Again, the main idea here is to minimize the problems through the early detection of microbial growth. We have also here the fuel system maintenance. The best way to prevent microbial growth is growth in fuel is to lessen the exposure of the diesel fuel to water. So there are various procedures that can do this, such as recycling of fuel through water separation and routinely discharging the water bottoms where the microbes grow. Fuel tank insulation, a procedure to stabilize fuel temperature, can also be used in the event that sludge has already developed. It should be removed fast and on a regular basis to prevent it from growing. Scheduling regular tank inspection, cleaning, and treatments are also recommended. So in dry dock, we clean the tank, but sometimes on board the ship, we also clean. So if we have a chance to clean, we have to clean while we are on ship. Next, we have also fuel treatment. So fuel and water tank bottoms are recommended to be treated to control the spreading of microbial growth. In fuel, removal of biomass or the sludge which has already developed is also needed. Again, diesel fuel, biocide, or a diesel microbial growth remover can help in preventing contamination. When choosing a remover, several factors should be considered, namely the solubility of the fuel water, compatibility with the system components, compatibility with fuel and other additives, speed desired to kill the microbes, and of course, industry and regulatory approval. So, for example, here we have diesel power. So I also ordered this chemical when I was on board the ship, diesel power. So this one is to treat against the what we call here the the microbial growth remover. So we have to treat the fuel with the diesel power. Next, it's essential to have adequate storage for marine fuel, but microorganisms can corrode fuel storage tank and systems, leading to the clogged filters and nozzles and degrade fuel. So Unitor diesel power biocontrol is specially designed liquid that protects fuel against microorganisms. So this is diesel power biocontrol. Diesel power biocontrol. So it protects the fuel against microorganisms. So it kills the microbial growth. It kills the microorganism. Diesel power. So I ordered this one when I was on board the ship. Features also of diesel power. So we have here. So features of diesel power: kills microorganism in fuel oil, keeps filters and nozzles free from clogging, prevents corrosion in fuel system and doesn't form any corrosive combustion products, safe for use on all materials including metal and synthetic rubber. So these are the features of diesel power. So diesel power is made by Unitor. Benefits. So we have also here the benefits. You can be sure that Unitor diesel power biocontrol will kill all or microorganisms or microbial growth. There have been no reported cases of bacteria becoming immune to this liquid. So meaning all of the bacteria is being killed with this diesel power biocontrol. With filters and nozzles clean and free from bacteria remnants, you can run a trouble-free operation. So those are the benefits of the diesel power. So for the recap, we have discussed the following. So the procedures for dealing with contamination of fuel of oils by water, fuel, in lubricating oil, solid debris or other contaminants, including recognition of unacceptable levels and possible consequences. We have also discussed the causes, symptoms, effects, and methods of treatment of oils that have been infected with microbiological organisms. So what to do next meeting? So our activity next meeting. So we will have a short quiz on the given discussion, and we will have also a random oral recitation. So, and after that, we will discuss the following: the details of bunkering procedures and arrangements, explaining the importance of the following correct procedures. We will discuss also the operation of the centrifugal separators and analysis the factors that affect optimum separation. We will discuss also the function and operation of the shipboard fuel blender and alternative fuel treatments. So that will be our activity next meeting. So this is the end of the discussion. So please subscribe my channel. Please click like and share. Please click notification button. And thank you for watching, and see you for my next video. Don't forget to subscribe.